Hello everyone, welcome. In this video, I'll try and explain to you what is an IP address. Okay, but before I go on, let's try and break this down. So we have here an IP address, but what is an IP itself? Right, an IP is a set of rules, okay, and standard that defines how data, again, bear in mind here, data is addressed, packaged and transmitted over a network. So underline the address with red ink. The reason why I'm saying this is the IP address is born from the internet protocol. So the internet protocol will have a set of rules that will define how a package is going to be addressed and packaged and transmitted over the network. Okay, if you understand this, what is a network? Before I again explain the IP address, the network is just a collection of two or more devices. What are devices? Devices are like your phones, your tablet, your TVs, your computers, anything that you can connect over your network is a device. Okay, so if you understand this, now what is the IP address? Like I said, it's a component part of the internet protocol, which is the IP. So what is it itself? Okay, it's just a value, a numerical identifier, okay, which is assigned to the device, which is your device, which is connected over your network. So in a nutshell, this is it. So it is like your house address or your phone number. Okay, why do we need it? So if somebody, a postman, want to send you something, okay, he will come to your address and deliver your package to your address, to your house, which is your address. If somebody want to send you a message over your phone, he needs to know your phone number and send you the message or the photo to your phone. This is how it works. It's like your address, your location. Okay, so this is it. So let's move on to the next slide. We have types of an IP address, and the reason why we have these types is initially we used to have what we call the IP version 4. The version 4 was what we used to know, but it got to a point we were running out. Why are we running out? Again, I will explain it. We were running out, and therefore we came out with what we call IP version 6. You might be wondering, what is the previous version? Where is IP version 1, 2, 3? Now we have 4. So these were like, laboratory tests. It never got released. Therefore, the only one we know is version 4. Okay. Right. So these two types, what are the difference? The IP version 4 is what we call the 32-bit address system. Right. I'll explain it back. The IP version 6 is what we call the 128-bit address system. So the 32-bit address system, what do we mean? Okay, this is born from how the machines read the IP address. Why am I saying this? So the machine don't really understand these numbers like 192.168.1.1. Okay, they read what we call binaries, the ones and the zeros and the ones. That is what the machine read. So to convert, the machine will convert these to binary. Okay, so these binaries, they are made up of 32. How do we get a 32? The machine will convert this to binary. When it convert this to binary, that to binary, that to binary, okay, this one will be 8 binary. So we call this binary octet. This one will be 8, this will be 8, this will be 8. So each dotted decimal is made up of 8 binaries. Okay, so we call this binary octet. Okay, so binary octet. So 8 of them. Okay, 1, 2, 3, 4. Each of them will be 8. So you multiply it, you get 32. Okay, so to get the whole IP address for IP version 4, okay, so this is 2 exponent 32. Okay, so 2 times 2 times 2 times 2 times 2 all the way to 32 will give you the whole IP range for IP version 4 here, which is like 4.3 billion. Okay, so as nowadays everyone have a phone, have one or two gadgets, one or two device, more than that. Okay, therefore we are almost running out, okay, of IP version 4. Hence we have, you know IP version 6, which will be, the 2 exponent 128. Just think about it. Almost every atom on this cell will probably have an IP. So this is apparently inexhaustible for now. We'll see how it goes. Okay. So IP version 4, this is dotted decimal. Okay. And then the version 6 is hexadecimal. Okay. Right. I hope this will understand. Let's move to the next slide and I will show you how, we can get this binaries. Okay, so these are the binary octets. Like I explained to you, how the machine is going to read this is to convert this number into binary. Okay, octet. How do we get this? Again, I'll explain it to you on the next slide. There is a sliding scale that I will show you, which is the binary values. Okay, this is what we use to convert this to that. Okay. Right. So the next slide, again, this is the bit values. So from the scale from left to right, all the way, there should be one here actually that was missing. Okay. So to convert it, let's say you got a number, the 192. Okay, the one we had earlier here. Okay. To convert it, let me quickly show you. The next slide will be more apparent. So this is the scale. You use this. Okay, so you want 192. How do you get 192 out from this? You pick the highest number, which is 128. Okay, so you take 128 from 192, you only go with 68. So the next one is 68. So 128 plus 68 is going to be, 192. So when this is taken, the number is complete or is taken, you put one there. So this is complete, you put one there. This is also complete, it's been taken, you put one there. The rest we haven't even touched them, so you put zeros here. That is how we ended up having one, because that is complete. Two, the next one that is complete, the rest is zero. Okay, so if you want to do another one, which let's say 255, right? To get 255, you add 128, so this is complete, that's one. 64 complete, one. 32 complete, one. 16 is complete, 8 is complete, one. 4 is complete. If you add all of them, and even there's a one here, you add it, you get 255. Yeah, that's why we get 255. That is, masking. I'll do a separate video and explain subnet masking on that. Okay, so this is it. So let's move to the next slide, and that will give you a complete IP, and then we're going to explain it. You've already done this. You know how we had the 192. So 168, let's do this one. Right, so 168, the first one, you go from the highest, so 128 will be taken. Right, if you add 64 to 128, it will be over 164. Therefore you skip that, you put zero here. You want a complete, you want the value which is set, which is complete. Right, so we'll skip this, so we put zero here. We move to 32, so you add 32 to 128. So if you add that, so that will be complete, so this will be taken. Okay, so 130, 160, so this will be 160, so this is complete. Okay, so the next one is complete. Remember, we skipped the 64, so that one we skip it, we had that. The next one, the 32, is complete, we had it. Okay, the next one is 16. Right, if you add 16 to 32 plus 128, is more than 168. Okay, okay, bear in mind 32 plus 128 is giving us 160. Okay, we only need 8, so we will skip the 16 and then we move to the next one, which is 8, and we add 8 to 160, we get 168, and therefore the rest tends to 0. So 0 0 0, so 1, which is the 128 complete. 0, we skip that. 1, which is the 32, we put 1 there. 0, 16, because we skipped that. 1, which is the 8, we added it. Okay, and we had 168. The rest we put 0 there. So if you want to get the ones, again, we just do one of them and you understand it. So one, you just looking for one which is complete. You look at it. No, no, you're only looking for one. No, 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 no. And here, we have one here. Therefore, all of these are 0, 0, 0, 0, 0, and then the last one is 1. Okay. Therefore, the 1 is 0, 0, 0, 0, 0, 0, 1. Okay, same as that one. I hope this helped. Again, rewatch the video. If you're not sure, please put it in a comment. Again, I'll be doing another video to cover subnet masking, and then we're gonna do side out range. The reason being, we'll be moving on to VPC, AWS VPC, which is more networking. If you're not sure how to work it out, IP address, you're gonna have problem here and there. So that's why I'm taking my time to go through this. Okay, so networking is key, whether you are DevSecOps, cybersecurity, cloud engineer, whichever role you are doing, you need to get grips of your networking, because this is how we control traffic coming in and out. Okay, I hope this helps. See you in our next video. Thank you very much. Bye bye.